Examples 3 and 4 from 6-7. So this is 6-7 part 2. We're going to work on graphing polynomial functions and determining the local maxima and minima. Now that we've studied factoring and we've spent a lot of time factoring, solving polynomial equations means we're finding the roots or the zeros, figuring out the end behavior, which we just learned in the first half of 6-7. You can graph a polynomial function, and these are the steps for it. Okay, so write those steps down and we will work through a few problems. This gets a little difficult, but with time and a little bit of patience, you'll be able to graph polynomial functions pretty well. Okay, so let's get into one. Example 3, graphing polynomial functions. Graph the function f of x equals that polynomial by going through the steps. I know we can graph these in our calculator, but we are going to practice graphing them by hand just so that we can understand our polynomial a little bit better. Step 1, identify the possible rational roots by using the rational root theorem. That's p over q. P is 6, q is 1. So our possible roots are plus and minus 1, 2, 3, and 6. Test the possible rational roots until a 0 is identified. I'm just going to grab one of those roots and just test it. Okay, you're going to use your calculator and find one, but we're going to just grab one and test it to see if it is a root. How do we know if it's a root? Well, we get a remainder of 0. So I'm going to do synthetic division and hope for a remainder of 0. -1, 3, -3, -2, +2, 4. Not correct. Let's try +1. This doesn't take long, so it doesn't bother me to test a few. 1, 5, 6, 6, 0. So x minus 1 is a factor, x equals 1 is a root. So from the previous slide, from our synthetic division, this is what we have. We factored out an x minus 1. We have left x squared plus 5x plus 6. Let's factor that trinomial. You can do a, c, and b. We have a times c is 6, b is 5, 2 times 3. Okay, divide by factors of a. I get, write this one down again, x plus 1, erase, x plus 3, x plus 2. So our zeros are 1, -3, and -2. Okay? So those are the things, that's where your polynomial crosses the x-axis. Pretty cool. Step 4, plot other points as a guidelines. We're going to try to find some points between the zeros, between those points. I'm looking for x's that are between 1, -3, and -2. 0 is always an easy one to graph. So we are going to evaluate the polynomial at 0. So you plug in 0, and you're actually going to get -6. And if you look at your polynomial, -6 is the constant. So this is also the y-intercept. You guys know that from quadratics. So that is your y-intercept. I just want to find one more point. So I'm going to do the point in between -2 and -3. So I'm going to evaluate at -5/2, which is 2.5. 2.5 is between -2 and -3. If I plug that in, I'm going to get, you have to trust me on that, or plug in your calculator. Let's go ahead and evaluate at -1 also. If I plug in -1 to the polynomial, I'm going to get -4. Okay, so I have these 3 points to plot and these 3 points to plot. So it really gives me a lot. So with my end behavior and all of this information, I have enough to plot my polynomial. End behavior. Okay, our leading coefficient, our degree is odd, and the leading coefficient is positive. So the end behavior, As x goes to negative infinity, your polynomial goes to negative infinity. As x goes to positive infinity, your polynomial goes to positive infinity. Okay? As we sketch a graph of the polynomial, okay, we have a lot of points to plot. So we know that all of our zeros are 1, -2, and -3. So we have 1, -2, and -3. We evaluated the function at f of 0 and got -6. And f of -1 was -4. And f of -5/2 was 0.875, just a little bit above. Okay, end behavior. As x goes positive, your polynomial goes positive. So that means this is going up. And s goes negative, your polynomial is going negative. And we sort of connect the points in between. That looks like my 3-year-old did it, but you get the point. Let's try another one. Okay, you guys need to try this one. Do the same steps. There's a lot of the same problems or the same numbers in there, so go ahead and try it. There's our first step. I'm going to move to the next slide and continue on. Okay, we're on step 3 here. Go ahead and push pause and keep going. Okay, the next 2 steps, I found the zeros, and then I chose 3 more points to evaluate my polynomial at. And let's move on. Okay, I have my end behavior described, and I started plotting my points. So as x is going positive, p of x is going positive, so we're going somewhere like this. And as x is going negative, p of x is going negative. So we're going like this. I should have put an arrow there. Now we're going to try to connect the points in between. Alright, one more thing to do. Okay, my phone chirped. Sorry about that. So let's get back to the lesson. Okay, the end of the lesson, we're talking about turning points. Turning point is where a graph changes from increasing to decreasing or from decreasing to increasing. So if we had this, that's a turning point, and that's a turning point. A turning point corresponds to a local maximum, right there, or minimum, right there. We're going to find local maximums and minimums with our graphing calculators. Some details. A polynomial function of degree n has at most 1 less than the degree turning points, and at most the degree x-intercepts. So if we had a polynomial of degree 3, that means it would have 2 turning points and 3 x-intercepts. A function has n distinct real roots, then it has exactly n minus 1 turning points and n x-intercepts. That's the same thing said a different way. Okay, our example. Graph of f of x equals 2x cubed minus 18x plus 1 on a calculator, and estimate the local maxima and minima. Step 1. This is all from the book, so it's laid out with the buttons you're going to use on your calculator. Graph. Okay, that means put it in y equals. The graph appears to have one local maxima right there and minima right there. Find the maximum and minimum. You're going to press second, calc, to access the calc menu. Choose maximum. The local maximum is approximately 21 point whatever. Okay, when you get that, remember it's going to ask you for the left bound, the right bound, and the guess. We've done this before, so you know how. Then we do the same thing to find the minimum. Second, calc, and minimum. It's going to ask you for a right bound, and a left bound, and a guess. Okay, the hardest part about this, I think, is trying to get your whole graph in the viewing window. Sometimes you have to change your window, your x min and x max, and your y min and your y max to get the whole thing in the viewing window. I think that's the hardest part. Because if you look at this polynomial, your y min and your y max are negative 25 and 25, and your x's are negative 5 and 5. So you're going to have to play with your window a bit. Let's try another one. Okay, try this one along with the book. I couldn't delete half of this to try to get it so it's a real you try, but go ahead and plug it into your calculator and estimate the local maxima and minima. So we're graphing it, and we find the maximum by doing second calc, and that's the maximum. So it's going to be a left bound and a right bound and a guess. Okay, and it's going to spit out the maximum. Notice the maximum is always the y value. Minimum, okay, left bound, right bound, guess, and the minimum is the y value. That's all we have for today. We'll practice some in class tomorrow.